This is a vertical projectile motion problem from the Physical Sciences Paper 1 DBE November 2023 exam. In this video, we'll be working through all of these questions and you will learn about how to interpret these problems and the techniques on how to approach these questions and many more other helpful tips and tricks. So without wasting any time, let us get straight into it. Here we have a ball of 0.5 kilograms which is thrown vertically upwards from the top edge of a building which is 15.3 meters high. The ball reaches a maximum height of 5.89 meters above the top of the building. The ball strikes the ground and bounces vertically upwards, reaching a maximum height at point P. The effects of air friction are ignored. This indeed confirms that here we are dealing with a projectile because by definition, projectile motion refers to the movement of an object where it's only the gravitational force that influences it. So let's look into the first problem. Using only equations of motion, calculate the speed at which the ball was projected upwards. Basically, we need to work out the velocity of this ball when it was being thrown vertically upwards. And since this was its starting velocity, we can refer to it as its initial velocity. We are not provided with any additional information with regards to the velocity of this ball during this motion. However, we do know that at some point it reached its maximum height as indicated by this peak. And what we know is that at the maximum height, the velocity of a projectile is always equal to 0 just before it changes its direction of motion. Additionally, the nice thing is that we do know the distance that the ball had traveled from where it was thrown to the maximum height, which is equal to 5.89 meters. So we can consider the point at which the ball was thrown vertically upwards to the point where it reached its maximum height. So we can call that velocity at the maximum height as its final velocity. And of course, as I had already mentioned, as the ball is undergoing this motion, it is experiencing a force of gravity, or in other words, the gravitational acceleration, which is always downwards towards the center of the earth. And of course, the magnitude of this gravitational acceleration is 9.8 meters per second squared on Earth. So what we can do is we can choose an equation of motion that can allow us to calculate this initial velocity using the information that we have. Additionally, always remember to choose and indicate your positive direction just before you start with your calculation. For an example, we can take upwards as our positive direction. If you examine the information that we have and compare to the equations of motions, you will find that using this equation, Vf squared is equal to Vi squared plus 2g delta y, we can be able to work out this initial velocity. As discussed, we do know that the final velocity is equal to 0 at the maximum height. The initial velocity is obviously what we are trying to work out here. And the force of gravity is going to be negative 9.8 because we are taking upwards as our positive direction. And then delta y is 5.89. And it will also be positive because this is the change in position as the projectile was moving from the top of the building to the maximum height, which is an upward movement. Therefore, the change in position will be positive. From here on, we simply need to solve for Vi on this equation and we can make use of a calculator. So we have 2 multiplied by negative 9,8 multiplied by 5,89. This is equal to negative 115,44. But then we can move this to the left hand side so that we are only left with the VI squared on the right hand side. So this will be positive 115,44 equal to VI squared. And then we simply need to apply a square root on both sides of the equation in order to find the value of VI. So the initial velocity is 10,74 meters per second. So we have successfully calculated the speed at which the ball was projected upwards. Now let us move on to the next question. Here we are firstly told that after the collision with the ground, the ball leaves the ground with a speed of 11,92 meters per second. So this is after the ball has changed its direction and moved downwards from the maximum height towards the ground up until it hit the ground and then bounces vertically upwards to point P. So what we are being told is that the velocity at which this ball left the ground is equal to 11,92 meters per second. Okay, so the instruction is calculate the amount of kinetic energy lost by the ball during the collision with the ground. This makes sense because due to the frictional force between the ball and the ground during the collision, some of the kinetic energy of the ball can be lost, for example, as heat energy or sound energy. The first sign of this is that the velocity at which the ball bounces off the ground will be less than the velocity at which the ball hit the ground, which we are not given in this case. But the reason I'm saying this, it's because we can be able to calculate the amount of the kinetic energy lost if we can work out the speed at which the ball hit the ground, as this can allow us to calculate the change in kinetic energy during the collision. So to answer this problem, the very first thing that we must work out is this velocity at which the ball hits the ground. We can consider the motion from the time when the ball reached the maximum height to the time where the ball hit the ground. We can say that the velocity at the maximum height is the initial velocity, and then this velocity when the ball hits the ground will be our final velocity. Now, what you must note is that we also do know the displacement of the ball from the maximum height to the ground, because that is simply equal to the height of the building as well as the maximum height it had reached from the top of the building. So we simply need to add up these two heights for the displacement of the ball from the maximum height to the ground. Again, if you examine this information, it's clear that the key equation that we can use in order to answer this question is still the same one as before. And likewise, we are going to indicate our positive direction, and it's always advisable to remain consistent with the same direction. As I have said, our equation will be Vf squared is equal to Vi squared plus 2g delta y. In this case, we do not know Vf, and we do know that Vi is 0, g is negative 9,8, and like I said, delta y is going to be 15,3 plus 5,89. So we can work out Vf. wait, because actually I'm making a huge mistake here. Our positive direction is upwards, and from the maximum height to the ground, the ball is moving downwards. The mistake that I am making is that I am making the displacement positive, whereas it should be negative, because this is a downwards change in position. Therefore, the displacement must be negative as well. So to make this easy, I'll just make the signs for 15,3 and 5,89 negative. So now that I have corrected that, we can just substitute everything into the calculator. So I'll just put this under a square root immediately. So we have 2 multiplied by negative 9,8 multiplied by negative 15,3 minus 5,89. So we will directly get our final velocity, and it's 20,38 meters per second. This is the speed at which the ball hit the ground. But as you can see, the speed at which it bounced off the ground is only equal to 11,92, which clearly shows that a significant amount of kinetic energy was lost during the collision. So this kinetic energy lost, I'll just symbolize it as a change in kinetic energy. This is going to be equal to half mvf squared minus half mv initial squared. And note that this time around, the initial and final velocity that I'm referring to is the velocity at which the ball hit the ground and the velocity at which the ball bounced off the ground. And we were also provided with the mass of the ball, and it's equal to 0,5 kilograms. So all that we need to do is to substitute here those values. So for mass, it's 0,5. The final velocity is 11,92. So again, let's subtract half m, which is 0,5, and then the initial velocity is the velocity at which the ball hit the ground, which is what we had worked out to be 20,38. So this is 20,38 squared, and then we simply need to plug in all of this into our calculator and find the amount of kinetic energy lost. So the answer is negative 68,31 joules, because this is kinetic energy. So this answer shows us that the amount of kinetic energy lost here is 68,31 joules. And here we got a negative simply because this is energy lost. So that negative sign makes sense here. Now let us move on to the next one. This time around, we must calculate the time taken for the ball to reach point P after leaving the ground. Okay, we know that the ball is gonna leave the ground or bounce off the ground with this speed, and it is now going to reach point P, and again point P is a maximum height. So at the maximum height, V is always equal to 0. So in order for us to calculate the amount of time it took this ball to reach point P, we can simply choose this equation of motion. And of course, we are still taking upwards as our positive direction. Vf is equal to Vi plus G delta T, we have the final velocity, the initial velocity, and we want to work out time. So the final velocity is 0. The initial velocity is positive 11,92. G is negative 9,8. And we need to solve for delta t. So let us transpose this negative 9,8 delta t to the left hand side, and then to work out delta t we simply need to divide by 9,8 on both sides of the equation. So this is 11,92 divided by 9,8, which is equal to 1,22 seconds. Simple like that, we are done with this question. And now we're only left with this one. We have the velocity time graph for the motion of the ball from the instant it is projected upwards from the top edge of the building until the time it reaches point P. Okay, so here that is, and we have got some key points that have been labeled here: L, K, T1, and T2. And the instruction is write down the numerical values indicated by each of the following. Firstly, the numerical value indicated by K. Well, we simply need to understand this graph. As already stated, it's a velocity time graph. So at time equal to 0, the velocity of the ball was L. So what must this be? It has to be the velocity at which the ball was thrown vertically upwards while it was still at the top of the building. And in the previous calculations we had, in fact, the very first one that we did, we had worked that out to be equal to 10,74. So the answer, that would be the answer to number 2 here. It would be 10,74. And then what happened after that? The ball was moving upwards up until it reached its maximum height. But what happens when a projectile reaches its maximum height? The velocity is 0. So from the moment the ball was thrown upwards, what we are seeing here is that its velocity was decreasing. Yes, the ball was moving upwards, but remember that this is not a position time graph, but it's a velocity time graph. So although its position was increasing because it was moving upwards, its velocity was decreasing because the acceleration was opposing that motion, which is why it eventually reached a velocity of 0, and that is the point that we define as the maximum height. And then what happened after that? After that, the direction of motion of the ball changed, and then the velocity started to increase, but in the opposite direction, which is why after reaching the maximum height, the graph is on the negative side. This is showing that yes, the velocity is increasing, but this graph was clearly drawn while taking upwards as the positive direction, which is why now as the ball is moving towards the ground, the velocity is 0. And then if that's the case, here at T1, it must be the point when the ball hit the ground, because from the maximum height, it will accelerate downwards or in the negative direction up until it hits the ground. And we had also established the velocity at which the ball had hit the ground. But there is no need for us to label it here because it's not even required, but we do know what this velocity is. And then what happened after that? The ball bounced off the ground. So as it is bouncing off the ground, it's now moving upwards again. So it has a positive velocity again. So K here is that velocity at which the ball bounced off the ground, which we had also worked out in the previous questions. And Well, in fact, we did not work it out, but we were given that it is 11,92 meters per second. So K here is equal to 11,92 meters per second. Also here, meters per second. And then T2 minus T1. We know that T2 minus T1 is basically the change in time, or equivalent to the time the ball took to reach its maximum height again, because you see, this is when the ball was bouncing off the ground, and now the velocity here is 0 again, which shows that this is now that second maximum height, which is point P. So we had already established in the previous question whether what was the amount of time it took the ball to move from the ground to point P, and that was equal to 1,22 seconds. So T2 minus T1 is simply equal to 1,22 seconds. So we have reached the end of today's video. As always, please make sure that you like this video and you subscribe to the channel if you would like to see many more videos like this one, and feel free to leave me your feedback in the comment section or ask any questions that you may have relating to this. I hope to see you on the next one. Good luck.